we are going to talk about application problems that are dealt with exponential equations. And if you recall, the general form for an exponential equation is y equals km to the x. There's 4 variables. Let's talk about what each of them mean. The y is the value that the equation is going to end up equaling. K is the starting value. M is your multiplier. And X, or T actually sometimes it's written, is your time. To come up with the multiplier, you're going to take the value of 1 plus the rate, and if the rate is a negative, it's a 1 minus the rate. Or you can talk about starting at 100 and adding or subtracting your rate, and then move your decimal over 2 spaces. As long as you know 3 of those 4 variables, you can always solve for the 4th. So let's begin with this problem. A coin had a value of $1.17 in 1995. Its value has been increasing at 9% per year. What is the value after 5 years? So the pieces of the puzzle that we know its starting value is 117. We know it is increasing at 9% per year. So based on what I wrote here with the 1 plus r, it's 1 plus the rate, and a decimal is 0.09. And we want to figure out what this is equal to after 5 years has passed. So at this point in time, you're going to just take your calculator out, type this in, and the value is equal to 1.80. Now, normally I would say round to 3 decimal places, but with money, you always round to the cents because that's what money is dealt in. Another type of application problem that is very common, especially in science classes, is the concept of half-life. And half-life represents how much or when or how much time something has, exactly as it sounds, half its life or half of its original amount left over. So if we have an element that has a half-life in 138 days, that means 138 days later, there will be half as much as there was to start. So if you have 100 milligrams to start, that's going to go in as our starting value. Now with half-life, our multiplier is always the same. You have half of it, which is kind of nice. We want to know how much will remain after 60 days. So the trick in a half-life problem is actually going to be your time. And the reason for that is because we have to understand that it takes 138 days to lose the full 1/2 amount. So your exponent is actually going to be time out of 138 days, because we need to figure out whenever we have our time, what fraction of the half-life does that represent. So in this case, I have 100 times 1/2 to the, now I want to know what's left after 60 days. So I can tell you right now, just by looking at this problem, that 60 is not a full half-life. There's going to be more than half of the element left over, because 60 is not a full 138 days. When I plug that into my calculator, I'm going to end up with 73.981 micrograms. Make sure your units match what the problem says. And what basically a half-life means is, since I started at 100, in 138 days, this number, this value, will be 50. So since I'm only 60 days into the 138, that's why there's still over 50 or 73 micrograms left over.